All right, guys, so today y'all are going to start a new unit, and I do have a sub this afternoon. So what I have done is I have written the notes for you. I'm going to solve them through the video, so y'all need to watch and take these, and then y'all have an assignment to complete, which I will give to you at the end of the video to make sure that you did listen to the whole thing. So, we're going to be talking about solving with substitution and elimination. This is the 3.0 lesson, so it's kind of like an intro, a refresher, what you've already learned before. To do substitution, you're going to probably want to pause and write this before I go into the examples. Is to isolate a variable, and then you're going to substitute your step one into into the other equation. You're going to solve it, and then you have to substitute your answer from step three into either equation, doesn't matter, and solve it, and then write your solution as an ordered pair. And a hint you may want to know is your answers are always alphabetical. They're going to sometimes give you letters that aren't X and Y, so you just need to know they're always alphabetical. So I have two examples written down. So again, like I said, if you need to pause, back that up and pause it and write it. Okay, substitution, you want to isolate a variable. So in other words, you want to look for a variable that doesn't have a coefficient with it. And this is the only one that doesn't have a coefficient with it. So to get this x by itself, I need to get this minus 4y over here. So I'm just going to rewrite this equation where it's going to be x equals. And if I want to get this minus 4y onto this side, I'm going to add 4y and then just keep that plus 9. So now this is isolated and by itself. Step one done. We're going to now take this and plug it into this equation. Since this says x equals, you plug that into the x value of the other equation. So we're going to do 2 times, and instead of x, we're going to put 4y plus 9. And then we finish the rest of the problem. Minus 3y equals 13. So step 2 is substituted in. We did that. We replaced x with our isolated, and then step 3 is to solve. So 2 times 4y would be 8y, 2 times 9 would be 18. Bring down minus 3y equals 13. Combining 8y and negative 3y give me 5y, and then I have plus 18 equals 13. I'm going to subtract the 18 over, which gives me negative 5, and I'm going to divide by 5, which gives me negative 1. So my y value would be negative 1. And then from here, what you're going to do is you're going to take that value and plug it back into this isolated equation because it's the easiest. You could plug it back into the original if you wanted to do more work. Now, I guess if you messed up on your isolation, then when you plug in, you would get the answer wrong. So we'll go ahead. We'll pick this one to plug into. We're going to do x minus 4 times negative 1 equals 9. So I get x plus 5 equals 9. And then when I subtract the 5, I'm going to get x equals 4. Oh, dummy, I did the math wrong right there. So that would be 4 when you multiply. I was adding. So when you subtract 4, you get 5. So my final answer, if I write this as an ordered pair, would be 5, negative 1. Oh, I should move that down so y'all can see it too. Now for the other example, I have 5x minus y, and I have 2x minus 4y. This y is easier to get by itself, but it's going to take 2 steps. So the first thing I would have to do to get it by itself is I would need to minus 5x. I want to do y equals. Okay, so if I minus the 5x, that becomes a negative 5x. But then I have a negative 1 here, so I have to divide everything by negative 1. So in reality, it's actually going to go back to being a positive 5x and a negative 13. And if you need to show that step by step, do so. If you don't, fine. So now that this is isolated, I'm going to plug this equation into this bottom one that I haven't done anything with, and it's going to go into y. We're going to do 2x minus 4, and then open up the parentheses and plug in the y, which is 5x minus 13, and it's going to equal 16. Okay, from here I get 2x minus 20x, and this will be a plus 52 equals 16. When I combine, I get negative 18x plus 52 equals 16. When I subtract my 52 over, I'm going to get negative 18x equals negative 36. And then when I divide by negative 18, I'm going to get x equals 2. Now I take this and I plug it back into one of my original equations. It does not matter which one. I'm going to go with the bottom one. We're going to do 2 times 2 minus 4y equals 16. This gives me 4 minus 4y equals 16. If I subtract 4, I get negative 4y equals 12. And when I divide by negative 4, I'm going to get negative 3. So my final answer, always alphabetical, would be 2, negative 3. And that's substitution. Now, if you need to pause for a second and get all that, do so. But now flip over to the back, and here's elimination. Okay, elimination, you're going to multiply one or both equations to get a constant term, but I want them to have different signs, one positive, one negative. Then you're just going to add the equations. It's always easier to do an addition problem, so that's why we want different signs. But if you don't get different signs, you would just be doing a subtraction problem. And then you solve. Whatever you get from step 3, you're going to plug into either one of your equations, and then you're going to write your solution again as an ordered pair. So if I look at this, I have x and I have 3. I have 2 and I have 1. These don't have the same numbers. So what you're going to want to do, you want to first make sure they are lined up, x with x, y with y, equals, and a constant with a constant. But you can modify this either way. You can multiply the top one by negative 3 to get these to be opposite numbers, or you can multiply the bottom one by 2 because this one's already negative 2. I'm just going to go ahead and modify that bottom equation by multiplying by 2. So this will now give me x minus 2y equals 1. I did nothing with that one. And this will give me 6x plus 2y equals, 60. I was saying 62, but writing 31. So 62. Now, if you notice, your y's are the same, but opposite signs. So this becomes an addition problem. So 1 plus 6 becomes 7x. Negative 2 plus 2 cancels out. And 1 plus 62 becomes 63. When I divide by 7, I'm going to get x equals 9. Now I just take this number and I plug it back into either one of my equations. I'm going to go with the top one, less work. We're going to do 9 minus 2y equals 1. I'm going to subtract 9 first, so I get 2y equals negative 8. And then I'm going to divide by negative 2, which gives me 4. So my solution to this problem will go x comma y, so 9, 4. Now, this does take a little bit less work than substitution. Here's your second example. We got 2x plus 3y equals 1 and x plus 6y equals 14. My x's are lined up, my y's are lined up, and my constants are lined up. Again, you have the choice. This one's a 2 and this one's a 1. So the easiest thing to do would be to multiply this one by negative 2 to get it to be opposite signs. So that top one I'm going to leave as 2x plus 3y equals 1. I didn't modify it. But now I'm going to just distribute this negative 2 to everything. And I get negative 2x, negative 12y, and negative 28. So now since my x's are the same number but opposite signs, this is just an addition problem. 2 plus negative 2 cancels. 3 plus negative 12 becomes negative 9y. And 1 plus negative 28 becomes negative 27. When I divide by negative 9, I'm going to get y equals 3. Now I just take the 3 and plug it back into one of my equations. Does not matter. I'm going to go with the bottom one again, the original. We're going to do x plus 6 times 3 equals 14. So I get x plus 18 equals 14. And when I subtract 18, I'm going to get negative 4. So my final answer for this problem would be negative 4, 3. So now, remember, always write your answers alphabetically, but you're going to do the assignment that's attached in there, and you only have to do the odds for this one. So if you have questions, make sure you ask when I am back tomorrow, and best behavior for the sub. See y'all tomorrow.